we just did, I just came up with the current through this R2 resistor using the approach saying that, okay, well, if there's a voltage across the battery, it would make a lot of sense if the voltage across this plus the voltage across that would be equal to the voltage of the battery, and that's how we figured it out, and the result, that seemed to be a pretty straightforward way of doing it. There's another way to do it that a lot of people use, is called the Kirchhoff's loop, in which you kind of walk through the circuit in a loop, and you think about how if you start from any point in the circuit, I like to start right below the battery, so the first step is the easiest step. And so you go from each point in the circuit, taking into account how much the potential jumps, and then if you get back to the same point, well, your change in potential is 0. Okay, so the change in potential of this loop, you have all this stuff in it, and that's all going to add up to 0. Okay, so that's going to be the Kirchhoff's loop. It actually doesn't even matter whether you do it clockwise or counterclockwise. So we could do it backwards, forwards, and you'll find out that we get the same result. So to make life easier, I usually start below the battery and I go from here to here. And so what should I put as the first term in our Kirchhoff's loop?
So I guess plus V battery.
Plus V battery. Okay. And then, so we're going to go up here, here, go from here to here.
Mm-hmm.
And now, have you ever heard it said there's a potential drop across a resistor?
Yeah.
So before, we didn't really talk about that before. We just like, well, the potential across this should be that, right? So if there's a potential drop, that means there's going to be a minus sign, right?
Mm-hmm.
And what's that going to be?
IR2.
IR2, right? IR2. And by the way, part of this determination is you have to sort of make a guess of which way the current is flowing. So in doing this minus IR2, I've guessed that the current is going down. So I don't know if you want to draw a little down arrow for the current. Does that make any sense at all, that the current would be going that direction in that circuit? Because it could be going the other way in principle, right?
Uh-huh.
So what do you think?
Would positive charges flow that way?
Yeah, so the current, you're right, so the current is in the direction of, as if positive charges are moving through the circuit. So let me ask you this. So this is the negative end of the battery, right?
Mm-hmm.
I don't know if people can see that.
Oh,
You're standing in front of it. So this is the negative end of the battery. So if we hook up this battery, the electrons are going to go in which direction through the circuit, probably?
This other direction.
Yeah, so if the electrons are doing this, then what would be the direction opposite to that? That. Okay. And so that current would be down, right? And so if I'm going with the current, then it's a voltage drop. So it's a minus IR. This is what I had up there. Okay, so we've got the battery here, the resistor. So we've gone, our Kirchhoff's loop, we've gone up to here and then down to here. And so now we have to go through the capacitor. And once we're here, we're home free. Like that's the last part. Now, before we get into the convoluted explanation of what this is, at the end of the day, it is either going to be a plus V capacitor here or a minus V capacitor here, where V capacitor is equal to, do you remember what it is?
Q over C.
Q over C, right? And so the following debate is whether to have a plus here or a minus here, okay? And yeah, okay, so the first thing to think about is that whenever you have any kind of electric field, the potential drop across that electric field is going to be minus E times whatever distance that you've moved. And so, but only if this distance is in the same direction as the electric field lines. And so we have to figure out what the electric field lines are inside of this capacitor. Are the electric field lines down or are they up? So what do you think, Blythe? Is it down or up?
So I think we'll have plus charges on this end and minus ones here. So the electric field will go that way. So
Right.
we are moving with it.
That's right. So the electrons originally on this plate are going to get sucked into the positive end of this battery, right? So they're leaving behind positive charges. And then the negative end of the battery is going to shove a bunch of negative charges on this end of the plate. And so the field goes from, the arrows always point from positive to negative, and so the field is going down. And so the way that we're going through the Kirchhoff's loop, we're going, I guess this is clockwise.
Mm-hmm.
So we went from here to here. So here to here, are we going with the electric field or against the electric field?
We're going with it.
With. And so that means D is positive, electric field is positive, kind of by definition. And so is it going to be a potential increase or a potential drop through the capacitor?
A potential drop.
Drop. Okay, so that means that instead of having a plus here, we had better have a minus here.
Mm-hmm.
Can people see that, or is it all smudged? That's okay.
Yeah.
And so we end up with this equation for our from our Kirchhoff's analysis. By the way, once we get to here, is it the same voltage as it is over here where we started?
Yeah.
Yep.
No resistors or anything.
That's right. So we can take this and we can just say, well, again, what we're trying to find is I. And so we have V battery. Just to rewrite it over again. IR2 minus V cap equals 0. And so what I can do is I'm going to add IR2 to both sides. Okay? And then, so that's going to cancel with this. And then what I'll do is I'll divide both sides by R2. Divided by R2. And so I'll end up with, running out of space here, I equals V battery minus V cap over R2. It looks more like an F than a T, but anyway. R2. So that's what I end up. Is it the same, or is it the same as I got last time, or did it turn out different?
That's the same.
That's the same.
Good side.
So you can do it the first way that we showed, or you can do it with the Kirchhoff's loop. Either way, you end up with the same answer. And so so now we're positive that this is what to do, right? So let's stick this into the code and see what it does.